Hey there, pretty lady, would you like to go out with me?
No. I'm not interested.
Why not?
Because your front is magnetized north, and so is my front. Therefore we can never hug because we will repel.
Oh. Magnetic forces. Haven't heard that excuse before.
I assume that was your attempt at sarcasm, because you obviously do know that magnetic forces is a serious dating problem for us robots. If it makes you feel better, I will explain what they are.
Well, I suppose a bit of dating advice could improve my game.
Firstly, magnets have two flavors, called poles, north and south. And you cannot have a north without a south.
And let me guess, you cannot have a south without a north.
That's right, although in the 1930s, Paul Dirac suggested the existence of a particle called a magnetic monopole. To date, all experiments to discover this one-poled particle have failed.
What does this have to do with us not being able to hug?
Well, similar poles repel each other, and opposite poles attract each other. And we are similar poles.
But how is a magnet made?
Wow, slow down, robot cowboy. First we must establish that there are two types of magnets, permanent magnets, and electromagnets. Permanent magnets is a substance where the configuration of the electrons is such that the movement generates a tiny magnetic field. And these make small regions, known as domains. These act together to make a permanent magnet.
Golly, that was ridiculously interesting to listen to. What about electromagnets?
An electromagnet uses a current-carrying coil of wire to generate a magnetic field.
You talk as though a change in an electric field creates a magnetic field.
That is correct.
Next you'll be tell me that a change in a magnetic field can then induce an electric current.
I was actually about to say that.
Wow, this is really interesting. In fact, I can already see the practical application of magnetic forces, such as a motor effect force, which could cause the rotation of a loop of current-carrying wire, assuming there is permanent magnets surrounding this.
You are correct, and that, in fact, that is a perfect summary of the motor effect. Well done.
So what does this force do? Other than rotate wire and to create a motor, of course.
Well, actually, this magnetism will apply force to a charged particle that is moving. You can figure out what happens using a useful rule with your left hand. Your thumb indicates the direction of the particle. The extended fingers indicate the direction of the external magnetic field, and the palm faces in the direction of the magnetic force.
Golly, this is amazing. You make learning fun.
Well, then you'll be happy to learn this force can even be calculated by multiplying charge, velocity and the field. And if the charge is within a wire, the force equals the product of the current, length and the field.
This means that if there is two current-carrying wires next to each other, we could use the hand rules to predict interesting patterns.
That is right. Also, this leads us to the generator effect. This is the production of electricity by magnetism.
What a brilliant idea for energy. It's perfect conservation of energy, is it not?
Unfortunately not, due to Lenz's law, which states the direction of a magnetically induced current will oppose the cause of the current.
That's unfortunate. But how do you know all this stuff?
Well, the relationship between electricity and magnetism was first noticed by Ørsted, who noticed a needle deflecting whenever current was induced near it. This led to further experiments which confirmed the relationship. Faraday helped develop the concepts of a magnetic field with Henry.
Wow, with this new information, I could invent some sort of maglev train, or a railgun, or a television.
It's all been done before.
Well, thanks for all this information. Now at least I know why girls turn me down. It's because our magnets repel each other.
Yeah. That's why. Cough.